Welcome to the Frequency Architecture Series, Part 5. Today we're going to be talking more about data on frequency. In Part 4, we talked about what a user account looks like. How does the user create that with the help of an application, and how does it get onto frequency? And we talked about user-centric data, data that is indexed based off of the user identifier. Today, we're going to dig into the final piece, time-centric data, and we're going to talk more generally about how does data look on frequency, how do you structure the requirements for data on frequency, and how you can create your own data on frequency. So first, let's start off with following the journey about posting content, because that's a great example of this time-centric data. It starts off in the same way as a lot of other data. There's an interaction between a user and an application, and the user in this application already have an established delegation that was created or added to the user's delegation on the chain. So this application has gotten the authority from the user to say, yes, I can post content on your behalf. But then what does the application actually do once it receives new content from the user? Well, first off, it has to go through the standard kind of application requirements, whatever that application has for content on that application. But then it's got a couple pieces that we care about from a larger network standpoint. First off, that content's got to be stored somewhere, right? The backend's going to store it, and it's going to be putting something, that content, as well as a few other pieces into storage. And then it's also has to tell the rest of the world that, hey, there is this new piece of content that exists. Because in frequency, the point of connection, the point of broadcast, so that the Strawberry application here can tell all the other applications about this new piece of content, is through that peer-to-peer blockchain. So what does this actually look like? So the backend has a couple pieces. It stores what are called batch files. These batch files hold lots of different pieces of content, or specifically the announcement of said content. And then the application is broadcasting out to the blockchain that there exists new content of this type for the rest of the world to consume. That piece of data on the blockchain is actually pointing to the batch file in IPFS. That's the content identifier. IPFS is great in that it provides a way to have content derived storage locations as opposed to location. So instead of a URL that the content might change behind, and if you want to get the content, if it moves somewhere else, you have to change that URL. A CID is always the same for the same piece of content, wherever it is. In the future, this might expand to support other decentralized storage possibilities. So we can look at this a little bit better when we look at how does it look to read content, right? So this Kiwi application here is looking out for new content. So it discovers that content via the blockchain. And again, the blockchain, the frequency blockchain, is the only piece that's in common between the Strawberry application and this Kiwi application. So it finds out about that. The Kiwi application gets that batch file from IPFS. It reads that list of announcements. It fetches the content behind those announcements, and then it's able to process that and show it to the user. And we'll see this as a common recurring trend. How do these applications manage to coordinate without any connection between each other? And the blockchain allows this coordination to happen. And one additional piece now to look at is how does the application, the Kiwi application here, know what content to look for, know that this content is a thing. So here's where we have the different data options on frequency that we need to dig into and learn about. So first, there are these questions that everyone needs to ask, right? The discovery of data. How do I want this data accessed? Right? This is that kind of question of, is it time indexed? Is it user indexed? But how do we want that data to be discovered by other applications? We have the actual physical storage, right? Where is this data being stored? Is it stored in IPFS? Is it on chain? How do I get this data? And finally, the most critical one here is the schema. How is this data structured? How do I understand what this data means when it's just sitting there? So first, let's dig in a little bit more into discovery. And again, we've already talked about this list, but to reiterate, we have account data, which is the specific data about the account that's specified by the chain itself. Great example of this is handles. Then we have your user-centric data, right? We went through last time. I want to discover something about this user. That's the social graph. That's some keys that are associated with the user. And then finally, we have this time-centric data, which we just saw, right? I want to know what's been happening over a point in time. And the content references are the great example of that. So let's look at the data storage options, right? So we have those data discovery options, and then we have these storage options. And really right now, there's two primary storage options. It can be on-chain or it can be off-chain. And on-chain storage is very limited. This is very costly storage, and it tends to be limited to encrypted data, public key and address data, relationship data. In general, this is computer-driven data, data that a computer needs to be able to read and that a computer created in some way, shape, or form. In contrast to that, we have our off-chain data storage, right? This right now tends to be IPFS, but it's at the end of the day, it can be defined by the specification. It can have secondary references. Batching is a great example of this, where it can contain a stream of messages all wrapped up into one big batch. It can refer to other content very easily. This is a very wide open set of data. It's often user-driven data that we don't want to store on-chain. You don't want to store, massive video files or anything like that in a peer-to-peer chain structure, such as frequency. So instead, we have this off-chain data storage to allow references to that. Now, data schemas. This is the heart of how we bring all of these different kind of questions and pieces together, right? So every message on frequency, every piece of data that isn't attached to the account or chain specific has a schema, right? And schemas answer three questions. The meaning. What is this data to humans, right? How does this data actually interact with other data and with humans, right? You could have the exact same data in one place and it's a post. In another place, it's a reply, right? So how do we actually know how to understand the meaning of the data? The structure. How do I take the physical bytes of this and turn it into understandable data? That's the deserialization of the data. And then finally, the rules for this data, the specification that this follows. In the case of a lot of the things we've been talking about, we use the DSMP, the Decentralized Social Networking Protocol specification, and it has specific rules for the data. An example is the batched content that come from DSMP. It states in the batch who each of those pieces of messages, those individual announcements and pieces of content are coming from, the user identifier attached to it. It is up to the rules, in this case, of DSMP, that data be checked to say, hey, is there a delegation that exists between this provider and this user for the provider to post this content on behalf of the user? If that permission is not there, then that rule is violated. So the data schema holds on to what's the specification, what's the rules surrounding this data from a human aspect and from any validations that need to take place. Finally, the data schemas also have permissions connected to them, right? So we have the signature-based permissions. These are often used for on-chain things that we want to make sure that the user has officially signed off on a one-time basis. And then there's the delegation-based permissions that are ongoing, where a provider might not need to ask for a signature every single time. Now, there are other settings and options that are associated with this, right? The discovery and the storage question are both answered by the schema on chain. It has, hey, which piece of discovery How am I supposed to discover this? How is it being stored? And then where is it being stored? How do I retrieve this data? It's critical to make sure that if you understand and want to adopt a schema, that you can always know how to retrieve it and how to process it, how to understand this data. So this frequency data schema bundles all of this together so that you trying to consume it or produce it know exactly what you're producing or consuming. In the end, the data flows follow a very standard pattern, right? The user creates some data, the application is going to process that data, frequency distributes the data, and other applications consume this data. And all that data is specifically on a schema or matching a schema. And this schema structure for data is a powerful tool for protocols and builders. You can build a schema that meets your protocol's needs and get lots of different applications to adopt it and use it and interact with it. And none of those applications need anything more than to know what the schema is on frequency. That's the end of the frequency architecture series. I'm so glad you were able to join us on the journey through frequency and excited to see you online and building on top of frequency.